Yeah. Hello everyone. Today we are going to cover the structure of atom. Okay. Here we are going to cover the model of an atom given by Bohrs. Okay. So Bohrs model of an atom we are going to cover. Okay. So first we have to cover the important postulates given by Niels Bohr in his atomic model. So first postulate says Niels Bohr revised. See what Niels Bohr has did. He gone through about all the previous models of the atom given by various scientists like Rutherford.
Yes, he went through it.
Yeah. Yes, he gone through all the point and he came with the new model. Okay. So Niels Bohr revised Rutherford atomic model and put forth the following suggestions for that model. Okay. So first suggestion is that he proposed that the electron possesses the specific amount of energy. See, the important drawback of the Rutherford model was he didn't explain the stability of atom, right? So he failed there. So Niels Bohr works on that model only. Okay, and he came with the solution. So the solution says electron possess a specific amount of energy which allows them to revolve around the nucleus. Means their energy level remains constant. That means,
so they do not radiate, they do not gain energy.
Yeah. If they will suppose if they will release, so same type amount of energy they will also absorb. So total energy exchange will be constant.
Yes, so the net overall is constant.
Yes, yes. So here the model given by Bohr. So it is nothing but the structure of an atom. As you can see here, at the center it is marked as a blue color, which is positively charged, called nucleus.
Yes, yes.
Yeah, and these are the different paths, okay, where electrons are revolving around the nucleus continuously, okay, and the electrons are filled by 2n square formula, where n is number of
subshells, sir.
Number of shells, not subshells.
So what is the difference between the shells and subshells, sir?
Okay, see, as you can see here in second cell, number of electrons are 8, right? So number of electron, if it will increase, so there may be some electron with higher energy, some maybe with low energy. So that particular cell splits into again different energy level. They are called as subcells.
Yes, so it's after 20, yes, atomic number.
Yes. So we have total 4 subcells like S, P, D, and F. Okay, these are the subcells. Okay.
Okay, sir.
Yeah.
In the electronic configuration, we'll use that, sir.
Yeah. So by next class onwards, not in next class, next to next means from 11th class onwards, you will learn how to write electronic configuration by subcells model like S, P, D, and F.
Yes,
okay.
Sir.
Suppose we have carbon atom. So carbon atom have atomic number 6. So what we used to write, it's electronic configuration 2 and 4. But in next class, next class, in 11th class, we will learn how to write electronic configuration. So its electronic configuration will be like 1s2, 2s2.
S on the capacity 2 and P and
so
4.
Likewise, you will write electronic configuration, but in higher classes, not here. Okay, not even in 10th class. So
there was some formula, right, sir, for number of subshells as well.
Yeah, I have given that Avbo principle in last class. That particular path.
Yes,
yeah, that particular path you had to follow for filling the electrons. Yeah. Okay. Third point. The electrons are confined to this energy level. Okay, means their energy level remains constant. It is not going to change. While revolving in this discrete orbit, the electrons do not radiate energy. So he explained that they do not radiate energy. Hence, these orbits are also known as stationary orbit because their energy level is not changing. So the distance from nucleus to the first cell, second cell, third cell will remain constant. Okay, it will remain constant.
Sir, it is not using energy, sir. Then how is it? Sir, it's not utilizing energy, right, sir? Then,
Yes.
sir, then how is it moving, sir?
See, we already explained that if it will absorb energy from the surrounding, if it will same amount of like if it will release same amount of it will absorb also. So total exchange of energy remains constant. Okay, so
Yes,
these
sir.
orbits like K, L, M, they are the principal energy levels. Okay, it is the same. It is same. It is not going to change.
Yes,
Yes.
yes, as we go on like far from the nucleus,
Yes, that's why they are
the
called
energy
as
level
stationary
will
shells. They are called as what? Stationary shells. Smaller the size of the orbit, smaller is the energy. So the shell, that K cell, which is closest to the nucleus, has smaller size, right? So have smaller energy. So as we are moving away from the nucleus, energy level increases.
Sir, when it is near the nucleus, the
Nucleus
shell size
energy
is
is
less,
less.
sir, and it can accommodate less electrons.
Yes. So as distance from the nucleus increases, energy level will also increase. Next, as we move away, see it is given already. As we move away from the nucleus, the energy of the orbit increases progressively. Okay, so it will increase. Okay, so we can say K cell have less energy than L cell. L cell have less energy than M cell, and so on.
yes, MS is less than N.
Yes.
Yes, sir, like more electrons can also be like affected.
Yes. Okay, next. The transfer of an electron from one orbit to other is always accompanied with the absorption or emission of the energy. Suppose if any energy level, suppose what we are like generally taking in consideration for the formation of sodium chloride. So sodium, okay, will lose the electron, okay,
Yes,
in
and
order
chlorine
to
will
form
gain one
Na
electron.
positive ion. Yes. So what basically it takes place here, suppose here we have nucleus of sodium, here we have first cell, here 2 electron, here second cell, here 8 electron, okay, and in outermost cell here we have 1 electron. So if you will heat that, so that electron will absorb the energy, its energy level will increase and it will lose that particular orbit. Okay, so in order to like if electron is moving into higher energy, it will absorb energy of, or if electron will switch from higher to lower energy, it will release energy. Okay, so absorption or release of energy takes place while losing or gaining electron.
So can you explain again?
Okay, let me move the screen aside. Wait. Okay, so suppose here we have the nucleus. Okay, and this is the outermost shell of sodium, and here we have 1 electron. So this, and here we have first and here we have second electron, right? Second cell. So here we have 2 electron, here we have 8 electron, and here we have 1 electron, right? It is case of sodium. Sodium have atomic number 11, so its
Yes,
electronic
11. So
configuration is
11
2,
electrons.
8 and 1. So in
1.
outermost cell we have 1 electron now.
Yes, sir.
Okay, so if you will heat that, if you will heat, so see this electron, that electron present in outermost shell has higher energy. So first it will absorb energy, so its energy level is going to increase, right? Due to increase in energy level, that electron will jump to the highest energy level, means it will move out from the shell. So sodium will lose 1 electron from its outermost shell and will form Na positive ion. Okay, so for that, that electron is absorbing energy, no? Is it or not?
Yes, sir.
Yes,
Yes.
sir.
But
Yes.
suppose in case of oxygen or let fluorine, atomic number is 9, its electronic configuration is 2 and 7, right? So in outermost cell, fluorine have 7 electron, right? Is it or not? Okay, suppose that electron,
Yes,
if we'll place here in its like electronic cloud, so that electron have higher energy than this particular cell. Means if that electron wants to fit here, have to lose energy, right?
sir, I didn't understand.
Okay, Suppose the first energy level have energy level at 10 kilojoule. Example, I'm just taking 10 kilojoule. Okay. Second energy level, let it is 20 kilojoule. I'm just taking example. And this electron, okay, which is present outside the cell, let have energy level is 25 kilojoule. Let example, suppose if you want to fix that electron in this particular cell, so what you have to do? You have to lose energy level up to like 5 kilojoule, then that electron will have 20 kilojoule and will fit in this particular orbit, right? Is it or not?
Yes, sir. Yes, sir.
Yeah.
So for electron
So,
to be removed, we have to observe energy and
yeah, in
electron.
case of, yeah, in order to remove electron, means lost electron, heat energy will absorb. In order to gain electron, electron will lose energy into the surrounding. Okay, so
Okay, sir.
here energy is being absorbed. Okay, and here energy is released. Okay, everyone.
The electron is, energy is released by the shell or the electron.
Electron. Cell will remain there only. It is the energy level will same for the cell. Only electron will absorb or release the energy. Yeah. Understood now?
Yes, sir.
Nikhil?
Yes.
Okay. So, where the transfer of electron, see, the transfer of electron takes place, no? From one orbit to other is always accompanied with the absorption or emission or release of energy. When electron jumps from lower energy level to higher energy level, it will absorb. That we already gone through. If electron will jump from higher energy level to lower energy level, it have to emit or release energy or emit energy.
Yes, sir. From outside the shell to
Yes.
inside the shell, I have to emit energy.
Yes. Okay.
Sir,
Suppose
how did Bohr prove,
Uh-huh.
sir? Sir, how did
Huh?
Bohr prove, sir, that his theory was right?
What?
Sir, how did Bohr prove, sir, that his theory was right?
Okay, how Bohrs has proved that theory is like, see, for formation of sodium chloride, sodium have to lose electron and chlorine have to gain electron. That we just gone through for the formation of NaF, sodium fluoride. Sodium has lost electron and form Na positive ion. That lost electron by sodium is gained by fluorine and fluorine will form negative ion. Now here the two opposite charge particles we have by loss and gain of electrons. So between them electrostatic force of is going to work.
It's a
And
strong
they combine
chemical
to
bond,
form
opposite charges.
yes, so they will form ionic bond. Okay, ionic bond. So here in order to lose electron, it is the you can understand, but like logically also.
Yes, sir. Metal and non-metal
Yeah.
form ionic bond, and non-metal
Yes.
form
So
shading of an
you can see these are nothing but energy level. First energy level, second energy level, third energy level. It is logically. Okay. Suppose if we want to put the electron in its outermost shell, we have to release electron of the electron, release from the electron. But if you want to release like loss that electron, so you have to increase energy level of that electron. That's then that electron is going to lose energy, right?
Yes, sir.
Yeah. So this is like there are many ways you can prove that. Okay, so this is all about the Niels Bohr atomic model. Any doubt here?
All clear.
Okay, so now we will understand distribution of electron in orbits. So we have already gone through that 2n square formula. Okay, 2n square. So let's discuss. I'm just moving the screen over here. Okay, so here we have center of the atom called nucleus. So this is the nucleus, and we know nucleus is positively charged, so I'm just representing here as positive sign. Okay, then we have first shell. So this is the first shell, and capacity of first cell is maximum 2 electron. That cell is called as K cell, beta K. It is named as K cell.
K shell. Yes.
Yes. Second, we have after K, we have
L shell.
L cell. L, yes.
8 electrons.
Yes. Sorry. Then we have
M
M shell.
shells.
Yes. So this is
18
M shell.
electrons.
Yes. Okay. After that we have
N shells.
N shell. N. Yes.
That's 32 electrons.
Little bit up like this. And M shell. N shell. N. So this is the N shell. Okay. So first is K, then we have L, then we have M, and then we have N, then O, P, Q, R like this. Okay. So here K means first cell.
That
Yes,
only 2 electrons, sir.
yes, only 2
Yes, K
electrons.
is the first. Okay. L means second cell.
Second shell, 8 electrons.
M is
Third shell,
third cell.
16 electrons.
Yes.
Sorry, 18.
N is fourth cell,
Fourth
and
shell,
so
32
on.
electrons.
Yes, and so on. Okay. So
Yes.
here we have formula called it is 2n square. Here
Yes,
the
sir.
n is what? Number of the cell.
Sir, that means that the K will be N equals to N, sir.
Yes, number of the shell. Okay. So now we have to calculate how many electrons we present in first shell. So I'm writing here number of electron in first cell. First.
Yes, 2 into 1 square, which is 2.
Yeah. So for first cell, n will be 1. So we have formula, it is 2n square. So if we will put n equals to 1, so it will be 2 into 1 square. So 1 square is 1 into 2 will be 2. So in first cell, 2 electron will come. So here I'm just writing 2 electron. Wait. 2 electron in first shell. Then we had to place n equals to 2. We have formula 2n square. So
It's
it
a
will
2
be
into 2 square.
2 square. So 2
So 8
square is 4.
electrons.
4 into
8.
2 is 8. So 8 electron will present in second cell. So I'm writing here 8 electron. Okay. Now for n equals to 3 means for third cell. So this
So
is
2 into
for
2 cube.
K cell. This is for L cell. This is for M cell. Okay, so 2n square we have formula. So 2 into 3 square. So 3 square is 9 into 2 will be 18.
18, yes.
So 18 electron will present in third cell. So I'm writing here 18 electron like this. Okay.
Yes, so then 2 into 4 square, which is 32.
Didn't understood, sir, from the first.
Yeah. So for n shell, n equals to 4, fourth number shell. So I'm writing here formula, it is 2n square. So 2 into 4 square. 4 square is 16 and 16 twos are 32. So in fourth cell, 32 electron will come maximum. Okay. So this is the capacity of electron, okay, to fill in a particular orbit or shell. Understood everyone, like how electron have to fill in a particular cell? Just take a screenshot.
Sir, can you send this note in the WhatsApp group, sir, or in the WhatsApp?
Okay.
Couldn't take the screenshot. Why? Sir? Sir, I couldn't take the screenshot. Why it is?
Okay. So here we have like a theory part, how electrons are being distributed. Okay. So according to the Bohrs model, electrons occupy the certain stable orbit or cell, and each cell has a definite energy. These orbits or cells represented by K, L, M, N, and so on, and they are number like 1, 2, 3, 4 like this. The maximum number of electrons present in the cell is given by the formula 2n square. So this is the formula where n is number of the cell or cells number. The maximum number of electron can filled in particular cell are as given over here. So for first maximum 2 electron, for second 8, for third 18, and for fourth 32 electron, and so on. The maximum number of electron can be accommodated in the outermost orbit is 8. It is according to the octet rule in order to acquire stability. Okay, or orbit or cell are filled in stepwise manner. Means first we have to fill first, second, third, like this. Electrons are not accommodated at a given cell unless the inner cell are filled.
Yes,
So
I told
first,
you this during the test.
yes. So first, but it is been like Auber principle is there, then Hund's rule is there. They like most of the theory had drawbacks also. So it is nothing but one of the drawback. Okay.
Okay,
So
sir.
this is all about distribution of electron in.
And then what is Bohr model, sir?
This is the same one that we are discussing here.
But then why do we even give the contribution of it to Bohr as well, sir?
Here we have like a really big concept called quantum number.